Hello, my dear friends, and welcome back to our coding whiteboard. Today, we are embarking on an exciting journey into one of the most fundamental and powerful parts of Java programming, the Java Collections Framework. This framework is absolutely essential for efficiently managing and manipulating groups of objects in your applications. We will explore its core interfaces, dive deep into various implementations and their performance trade-offs, look at a practical example, discuss advanced features, and highlight common pitfalls. By the end of this tutorial, you will be equipped to choose the perfect collection for any programming challenge. So, grab your virtual pens, and let us begin this insightful learning adventure together. Whiteboard animation image, clean white background, dark marker handwriting. Show a whiteboard with the heading core interfaces. Below, draw a simple hierarchy, collection interface at the top, branching into list, set, and queue. Separately, show map interface. For each interface, include a small icon or quick note, list, ordered, duplicates OK, set, unique elements, queue, FIFO, LIFO, map, key value pairs. A clearly boxed code snippet shows basic interface declaration. Now that we understand the interfaces, let us dive into their concrete implementations and, more importantly, the performance considerations when choosing one. This is where the advanced aspect truly comes in, my friends. For the list interface, we have ArrayList and LinkedList. ArrayList is backed by a dynamic array, offering fast random access but slower insertions and deletions in the middle. LinkedList, using a doubly linked list, excels at insertions and deletions but is slower for random access. For set, HashSet provides very fast operations using a hash table, but it does not maintain order. TreeSet, using a balanced binary search tree, keeps elements sorted but has slightly slower operations. Similarly, for map, HashMap offers excellent average case performance for key-value storage without order, while TreeMap stores entries in a sorted order based on keys, using a red-black tree, which can be slower. Your choice here critically impacts your application's performance, so choose wisely based on your specific use case. Let us solidify our understanding with a practical example, building a simple student management system. Imagine we need to store student records, each with a unique identification number, a name, and a list of courses they are enrolled in. A HashMap is an excellent choice for storing students, where the student's ID can be the unique key, allowing for very fast retrieval of student objects. Within each student object, we can use a HashSet to store their enrolled courses, ensuring that each student is enrolled in a course only once, thanks to the set as uniqueness property. We will demonstrate how to add students, enroll them in courses, and then iterate through our student database to display all the information. This example showcases how different collection types can be combined effectively to solve real-world problems. As we become more proficient, it is equally important to be aware of advanced features and common mistakes. One crucial advanced topic is the proper use of equals and hashcode methods for custom objects that you store in HashSet or HashMap. If these methods are not correctly overridden, your collections might not behave as expected, leading to duplicate entries or failed lookups. Another powerful tool is the collections utility class, which provides static methods for sorting, searching, and other common operations on collections. Additionally, integrating with the Stream API application programming interface allows for powerful, functional style operations on your collections. Regarding mistakes, besides equals and hashcode, new developers often choose the wrong collection implementation, leading to performance bottlenecks, or they might encounter concurrent modification exception when modifying a collection while iterating over it without proper synchronization. Always be mindful of these points. And just like that, we have reached the end of our advanced journey through the Java Collections framework. We started by understanding the core interfaces, list, set, queue, and map, which act as the fundamental contracts for data structures. We then explored their specific implementations like ArrayList versus LinkedList, HashSet versus TreeSet, and HashMap versus TreeMap, emphasizing how to choose the right one based on performance needs. We saw a practical example of managing student records to demonstrate real-world application. Finally, we touched upon advanced topics such as overriding equals and hashcode for custom objects and discussed common pitfalls to avoid. Remember, practice is key to mastery. Keep experimenting with different collections and their methods. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming content. Happy coding, and I will see you in the next video.